HFIR is, the facility is a national treasure. It really is. There's so much important work that we do here that benefits society, from the production of isotopes that are used for industrial purposes, for medical purposes, like for the treatment of cancer, for the exploration of materials, improving the strength of materials, criminal forensics, many security benefits as well. Airport security is another great use of the facility and the isotopes that we produce here.
Nuclear reactors give access to chemical elements, to particles that are nowhere else found. And so nuclear reactors were invented 60 years ago, 80 years ago. They played a major role in the Manhattan Project, and we keep using that fantastic invention today. It gives us access to something that cannot easily be found anywhere else. We can find things that are relevant for very special material that we use in computers, materials that will be necessary when we want to have the next generation of quantum computers. If you want to understand Alzheimer's better, we need to understand how proteins work. Neutrons can make a lot of the active ingredients in those protons visible. And with a machine like HFIR, you get access to all of that information.
HFIR is not just an institution, it is a culture. It's a culture of world-class excellence in operations and science, that we operate safely and that we aim for the highest level of scientific excellence.
I'd say that it's crucial that HFIR continues and operates into the future. One of the main reasons is that we support many different areas of national need. One of these areas is isotope production from all sorts of sectors, medical sectors, geological exploration areas, even into spaceflight.
There's two primary applications of the High Flux Isotope Reactor. First, as the name indicates, it's isotope production. And HFIR produces many different kinds of isotopes, but there's a select few for which there's only two places in the world that you can produce those isotopes. One of them is called californium-252 and one is nickel-63. And the applications of californium and nickel, these isotopes of californium and nickel, are in energy, national and homeland security, and healthcare. And HFIR is the majority supplier in the Western world. So nuclear reactors produce neutrons that are used to be able to probe material properties. Think of it like being able to see into materials, but rather than seeing with light, we see with these subatomic particles called neutrons.